Linear probabilistic modeling. Now, some of you may ask, what is it? And it's quite what it sounds like, a hard phrase to say and a hard thing to comprehend upon first reading. However, it's quite basic to understand. It's just a basic probability model that uses a regression line or line of best fit to predict outcomes based off of what you're comparing. Now, this line of best fit has a slope formula very similar to y equals to mx plus b, where here it's actually y equals beta naught, which is the y-intercept, plus beta x, which is your slope coefficient and independent variable, plus epsilon, a random error term. But rather than just telling you what any old textbook could tell you, let's look at real-world examples to help you better understand what linear probabilistic modeling is. Let's look at weather trends. So it's been snowing for 20 days and there's been 400 car crashes over this time. We could then use now information like that to make a linear probabilistic model that would show over X amount of days of snow, there'll be X amount of car crashes, and we can predict within reason what that would be. Or we could look at home mortgage loans, where you can compare the annual income you bring home to the amount of money you would be approved for a home loan, where you can, again, make a linear probabilistic model and be able to predict within reason what that would be. Or in an engineering setting, we could look at the particles per square inch on film being produced, whether it's going to be approved to be sold or not approved to be sold. And we could look at it in terms of how much we produce and whether or not 10 feet or 70 feet, 100 feet, 1,000 feet would be able to be sold because the particles per square inch are low enough. And with the linear probabilistic model, we can then predict where an optimal spot for producing amount is, whether it's 10 feet, 20 feet, 30 feet, 40 feet, 100 feet, 1,000 feet, whatever. We can choose that and decide what it would end up being. So linear probabilistic modeling can also be used to help optimize our procedures and figure all that out. But anyways, this was a short clip on linear probabilistic modeling.